Hello everyone, this one is the fifth problem of ILD. So this one is the statement: draw the ILD for shear force and bending moment for a section at 5 meter from left hand support of a simply supported beam. The span of beam is 20 meter long. Okay. Hence, calculate the maximum bending moment and shear force at the section due to an uniformly distributed rolling load for length 8 meter and its intensity is 10 kilonewton per meter run. Okay. So, span of the beam is 20 meter. We have to calculate the maximum bending moment and maximum shear force at section C, which is 5 meter from A and 15 meter from B. Okay. On the beam there is a traveling UDL. Okay. The UDL length is 8 meter and its intensity is 10 kilonewton per meter, which is traveling from left to right. Okay. So, we have to calculate the bending moment, shear force at section C. Okay. So, first we have to decide how much of UDL should be on its left side, right side of point C. Okay. So, we have to make the calculations. Before this, just draw a bending moment diagram for section C. Okay. Suppose I want to find out the bending moment at point C. So, I have to draw a bending moment diagram, okay, at section C. This is ILD for bending moment diagram at 5 meter from A. Okay. So, this ordinate is calculated by AB by L. A is 5, B is 15, L is 20. You will get 3.75. Okay. So, first calculations of maximum bending moment. Maximum bending moment will occur at point C. Okay. So, let us see this statement: maximum bending moment at C due to a UDL shorter than the span occurs when the section divides the load in the same ratio at its divide the span. Okay. We have to place the UDL in the ratio of its span. Okay. On point C, its left side is 5 meter, on right side is 15 meter. So, we have to decide the UDL lengths. Okay. So, let us see the calculation in the above figure. AC by BC, okay, A to C, then by BC is equals to A1C by B1C. Okay. So, we have AC is 5, BC is 15, A1C and B1C. We have to calculate this length A1C and B1C. Okay. If you calculate this ratio, you will get 0.333. Okay. Okay. If I suppose I say A1C is my x, so B1C become 8 minus x because total length of UDL is 8. Okay. So, x by 8 minus x. If you calculate these equations, you will get x value 1.98 is equals to, or round up is 2 meter. Okay. So, the A1C becomes 2 and B1C become 6. Okay. In such a way, you have to place the UDL. So, you will get the maximum value of shear force and bending moment. So, at A1 you have to find out this ordinate, at B1 you have to find out this ordinate by symmetry of triangles. Okay. Now, make the calculations of maximum bending moment. So, maximum bending moment is equals to intensity of load multiplied by area of ILD under the load. Okay. So, our intensity of UDL is 10. Okay. Then area of only this area. Okay. This shaded portion. So, just take the average height. Fortunately, these two ordinates are same. Okay. So, 3.75 plus 2.25 by 2. We have to take the average height multiplied by its length. Okay. Its length is 8 meter. 6 plus 2, that is 8 meter. Okay. if you calculate this one, you will get maximum bending moment, that is 240 kilonewton meter. Now next calculate the maximum shear force. Okay, so again draw a line diagram of beam of 20 meter span, section C at 5 meter and from A and 15 meter from B. Okay, our UDL is 8 meter length, its intensity is 10 kilonewton per meter. We have to find out the shear force, but it is traveling load, so there are two shear force, positive shear force and negative shear force. Okay, so let's say just draw a shear force diagram for section C. Okay, this one, if it is 1, so how much of this one? So by symmetry of triangles you can calculate this ordinate. Similarly for this one, if it is 1, this one will be 0.25. Okay, so if I placed the whole UDL on its right side, okay, right side of C, so maximum positive shear force will occur. If I placed the UDL on its left side of C, so maximum negative shear force will occur. Okay, so calculate the maximum positive shear force. Maximum positive shear force occurs when the tail of the UDL is at C as it travels from left to right. This is our UDL which is traveling from left to right. Okay, so this one is my head, this one is my tail. If I place the tail of UDL on point C, so it is just on its right side. Total length of UDL is 8. Okay, so at this point we have to calculate the ordinate. If it is 0.75, so find out this ordinate, so you will get 0.35. Okay, so maximum positive shear force is equals to intensity of UDL multiplied by area of ILD under the load. Area of ILD under the load. Okay, so intensity of UDL is 10 and area, average heights of this portion 0.75 plus 0.35 by 2 multiplied by its length. Its length is 8 meter of UDL. Okay, so you will get 44 kilonewton, not kilonewton meter. This one is the shear force. Okay, so 44 kilonewton. Similarly, calculate the negative shear force. Then maximum negative shear force occurs when the head of UDL is at C as it travels from left to right. Okay, if I placed the UDL head of UDL on point C, so whole left portion will covered by the UDL. The span on its left side is 5 meter, but length of UDL is 8 meter, so it look like this. Okay, so only considered this much portion, ignore this one. Okay, so whole negative portion will covered by the UDL. Okay, so just make the calculations. Maximum negative shear force, so intensity of load multiplied by area of ILD under the load. Okay, as it is negative area, so minus 10 intensity of load multiplied by area of ILD under the load. Area of ILD under the load. Okay, if I place the UDL on its left side, if I head of UDL on its C point. Okay, so a triangular area is half base into height. Base is 5 meter, height is 0.25. Okay, from this one you will get 6.25 kilonewton. Okay, this one is the maximum negative shear force. Okay, thank you.